Hello everyone, my name is Maia. I hope you are all having a great day, FCT Day in Costa Rica. And today I'm here to speak about FCT's view of how to produce green cement. We built a very comprehensive presentation that you can always go back to. We'll put it in our website as well. Come back to us in case of questions or comments. First of all, I will talk very briefly about the company. I don't think we have so much time, but FCT has three different branches. One making FCT flames, which you probably saw before in the Olympic Games. One is FCT AgTech. We are doing online analytic equipment mainly for process control, clinker, cement, and so on. And the third part of the company, that is what we are here today to speak about, is the FCT Combustion. We have different offices in different parts of the world in order to be closer to our client. We are close to complete our 40th anniversary, and our main experience comes from cement. So most of our engineers are coming from cement industry, but we also are working in different other industries. As we work in different types of industries, we can bring technologies that are very successful in one industry to the other. So this is one good point in working in different industries. When FCT started, we started only as main burner suppliers for the Rotary kilns, but today with our specialists, our engineers, we are able to help the cement plants in every aspect. Here's just a list of products that we can supply. Obviously, Rotary kiln burners, that's where we started. Different types of burners for other industries, hot gas generators for every type of fuel, including alternative fuels, 100% alternative fuels, different calcining systems, including clay calcination, and every accessory required for the other equipment to work. Apart from the equipment, we are also supplying services, engineering services, that are our manufacturing capability. And then now we come really to the topic of today. As I mentioned, I will jump some slides, but it's clear to everybody that CO2 is a problem, especially in cement, because if you are producing cement based on clinker, you are inherently producing CO2. There are ways to minimize it. One way to minimize is to not use clinker. So there are other types of materials that can be used and also have hydraulically binding characteristics, such as these ones on the screen, that we can get from other industries. But as we know, these are getting more and more scarce, so we need other solutions to replace these materials. One of these possibilities is obviously the calcined clays. Here, just a very basic calculation to show us how much we could reduce in terms of CO2. We're talking about only the CO2 coming from the material, a reduction of about 30%, right? And then there's an additional reduction because you're saving fuel, as calcined clays, you don't need so much energy to produce it. Basically, what you want to do, you have aluminum silicate oxides in the clay that you have to heat it, and you need to remove the hydroxyl component from the clay. Basically, what you do, you start heating the clay. There's a first period around 100 degrees, a little bit above, that you are removing the moisture. If you continue to heat the clay, there's a second period that is the important one. That's the clay activation, in which there's a important mass reduction in the clay, and this is exactly the hydroxyl leaving the clay itself. And then if you continue heating this particle, you can then start losing reactivity because there's a recrystallization of the clay, and this is what you don't want to do. So the target during clay calcination is to heat the clay up to this point, so until the end of the clay activation, but before the start of the recrystallization. There are three main types of clay. I don't go here in details, but the three main ones, kaolinite, light, multimilionite, can be used. Also, other types of clays can be used. And basically, here is just a comparison of these three types of clays, kaolinite, light, and multimilionite, to show in red the temperature for calcination, for activation of the clay, and the temperatures for recrystallization. One important point that we should talk about is about color control. Obviously, differently from cement, so if you have a brown clinker, this has impact on the quality of the clinker. But in case of a clay, there is no correlation between the color of the clay and its mechanical resistance. But there is a psychological influence in the buyers of this cement. Basically, what happens is that you have iron in the clay, and the iron can be under different forms, but mainly these two: hematite, which is on the red-brown color, and magnetite, which is more on the gray color, like the clinker. When you hit the clay above 650 degrees, most of the hematite will become magnetite, and that's what we want. The problem mainly is when we start cooling the clay back for transporting for storage, magnetite tends to go back to hematite, becoming again red-brown color. There are different possibilities to control this. So one very well known is to control the atmosphere of the kiln, especially in the cooling area. You can keep the iron in the magnetite form. There are different ways to control the atmosphere, but they all have, let's say, some problems associated. We, as FCT, we developed a new process patented by us to keep the iron in the magnetite form. Basically, what you do, you add some material easy to find closer to your plant, to the clay, and this reacts to the iron and keeps the iron in the gray, in the magnetite form, keeping the clay itself in the gray color. FCT, we are able to supply two different technologies for clay calcination. One would be a flash calciner, one would be a rotary kiln. I think this puts us in a very good condition because we are not forced to try to sell to you the only equipment that we have, because we have both. Here we have some characteristics of the flash calciner. I will go through this. But this is basically how a flash calciner would look like. Here we see a hot gas generator for alternative fuels. The temperature of this hot gas is depending on which type of clay that you have. The calcination temperature of each clay is different depending on the composition of the clay. But you would put these hot gases into a calciner loop. And there's a few cyclones first on the top to preheat the clay. Then there's one where we are separating the calcined clay from the rest of the gases, and at the bottom there's some sort of cooler that can be in different types of technologies depending on the goals of the project, and we have a couple gas filtering systems to comply with these standards, right? Here, for example, a picture of one of our hot gas generators for alternative fuel, and we have also pilot plants that we can use in South America and in North America. A rotary kiln, obviously, is equipment that everybody knows very well. I will not go into details here. There's it's a more forgiving equipment, but it's harder to use alternative fuels, for example, because of the reduced temperatures inside the kiln. So we can use different types of dryers, including a grinding together if necessary. As I said, different types of hot gas generators can be used for different fuels. And here, just a very easy, fast comparison between flash calciner and rotary kiln. Basically, the flash calciner is like a calciner in a pre-calcining kiln, so we are very precise in the temperature control. The particles must be very fine as you inject them into the flash calciner. So it depends on the case and depends on the clay that we are using. Sometimes you need to grind it. Sometimes they are already fine enough. They are just agglomerated because of water. The flash calciner has a much lower amount of refractory, so you can start preheating, and after 2 hours you're already producing calcined clay. In terms of energy consumption, fuel consumption is a much it's a slightly lower amount. Yeah, and then you can add the calcined clay coming from the flash calciner directly to the separator of the cement mill. Most of the particles will pass through and go directly to the cement. And the rotary kiln, as I mentioned, much more forgiving equipment. You can inject into the kiln very large particles. The rotary kiln itself already works as a sort of dryer, but there are some other points that are not so interesting, like there's a low secondary air temperature, and this limits us with the amount of alternative fuels that we can use, and you need to grind the clay after it passes into the kiln. There's a huge advantage of the rotary kiln, that is that in some plants there's already a rotary kiln stopped, and so you can repurpose at a very, very low cost the existing kiln to produce calcined clay, and back if you wish to. Now, this is the question that everybody makes: which one is better, flash calciner or rotary kiln? There is no one-fits-all solution answer. In each case, you have to understand how much is the moisture, what is the characteristics of your clay, and so on, and then you come up with the optimum equipment. In any case, both rotary kiln and flash calciner can be used, but for each case, one of the two technologies will be best suited. We developed a diagram you can see in our website to help you just to navigate through these decisions. As a first overview, when we are talking about the stages of a project, I think the first stage, phase one, raw material characterization, is the most important point, because from here you get all the characteristics of the clay and how these characteristics will impact the rest of the design of the plant. So it's very important to conduct, first of all, a very through laboratory characterization, and then come to a pilot processing. So as I mentioned, we have plants in the Americas for that, South and North America for that, both for rotary kiln and for flash calciner. And this will give us the information required to design the rest of the plant. Why FCT? So as I mentioned, we were involved in dozens of projects in the world. My first job related when I was fresh from university was with a burner for calcined clay for a rotary kiln. And our team of specialists, they are involved with this since the 80s, since before even I started at the company. And we can supply the whole process from the beginning to the end. As a conclusion, there are different technologies, there are different concerns about how to produce clay, color, but what is important is that you have to look case by case. Thank you very much.